Welcome to week 5 of GEOG473 673. This week is all about shapefiles. Plotting them, parsing them, reading their data, manipulating them, curating them. And we're going to be doing that today with a few different shapefiles from the datasets folder. Now, before we progress into the tutorial, I've mentioned this other times, but this is where it becomes crucial. You are going to need to download the datasets folder by just downloading the entire GitHub repository. Now, the reason that you're going to need to do that is because we're going to be using this folder right here called CFMS shapefiles. So notice there's 6 different files in here, and you'll notice that when we actually just load the shapefile, we're only loading one file, the .shp file. However, that function behind the scenes is reading and gathering data from the SHX, from the PRJ, and from the DBF. So these other files are helper files for the main primary shapefile. So make sure that you have them downloaded and all in the same folder. They all need to be residing in the same folder for this to work. Now, back to the tutorial itself. Shapefiles are just polygons that contain geolocated data. And shapefiles are one reason why somebody might use ArcGIS, which is a good program to deal with shapefiles. However, you'll find that R, once you get the hang of it, is just as good as handling shapefiles, and it's faster than ArcGIS. We're going to be mostly focusing on 2 packages today, and those packages are RGDAL. And for those of you who don't know, RGDAL is based on a piece of software that's free. It's called GDAL, and it's great for spatial transformations, for geolocation, for converting to a new projection, all from a command line tool. So it's based on that. So GDAL is a great thing. RGDAL is also very useful. The other package we're going to be working with today is called SP Spatial Points. It's the sister package of SF that we used last week, which is Simple Features. So we can read and curate shapefiles with either of these packages, and then we use ggplot2 to plot out the data. So the data that we're going to be using today is the CFMS shapefiles, and we need, as I mentioned before, we need all of the files from this folder to stick together. They all must be in this folder, they all must stay there. So we're working with the Coastal Flood Monitoring System for the state of Delaware. This is actually what we're going to be playing with right here. So it talks about, we basically have a map of 48-hour potential of flood depth for these different water basins along the Delaware Bay. So this is actually a sophisticated model. It takes in something like moon phase, takes in wind direction, and it can kind of backtrack and tell you what the maximum flood depth would possibly be in the next 48 hours, given the conditions and the forecast of weather. So we see that in this case, for this scenario, the max flood depth potential is pretty low. And that's mostly due to the fact that we don't quite have the strongest winds that are pushing water directly onshore. But, this is just, things can change. So this is not the best example of it in action, but it's still very useful, especially given storms or different wind events. It doesn't even have to be necessarily a storm that hits Delaware. It could be a storm that hits North Carolina, and just the winds that echo off of that can actually, at the top of that low pressure system, can really slam wind into the coast and thus flood because of water. So for those of you who don't know, Delaware is a very flat state, and it's very, very close to mean sea level. So it floods pretty easily. This is a really useful dashboard, and we're going to be recreating this map here. So I'm going to copy over all of these packages that we're going to need. So you might need to install SP, RGDAL. We're also going to be installing a function called ggmap. And then we're also going to need a couple other functions, scales and viridis. All right, and here we go. This is the function that we're going to use from our GDAL. So the first function is read OGR. So read OGR comes from the RGDAL package. And so you'll notice right here it gives us a little bit more information, and here's GDAL. It's loading GDAL in the back end. It's loading proj, which handles different projections. These are both command line tools. And now we can actually take a look at read OGR. There we go. So it reads vector maps and converts them into spatial objects. That's what's going on here, and it's a very useful function for shapefiles. So here we go. We're going to load in the CFMS watersheds.shape. So now this is already connected to my folder. So for me, it's documents, GitHub, GEOG, datasets, CFMS, shapefiles, and then finally the shapefile. Now, remember, when we're just reading in this file right here, read OGR is touching every other file in this folder. The PRJ, the DBX, the SHX, all of those different files it's touching and reading and gathering information from. So now we have a spatial polygons data frame. It has an extent, has a number of features, it has a coordinate reference system. Now, the first thing that I'll note, and the reason that we're practicing with this particular dataset and shapefile, is because it is a crazy projection. It is a transverse Mercator with offset longitudes and latitudes. And the extent is in Mercator units, it's not in latitude longitudes. And so it makes things a little bit more difficult to deal with because, we're not on a flat grid. But yeah, the class of coast.shape is a spatial polygons data frame. I found that out just by printing it out too. And the other thing is we can print out, notice how we're going to print this out here. If I want to print out the projection, instead of using a $ like we're used to query different variables or different objects within an object, we're going to use the @ symbol. And that's just the way that spatial polygons data frames are set up. So we have data, polygons, plot order, bounding box, proj4 string. There's a couple of different things we can use with the @ symbol. And that's just the way that shapefiles are constructed with read OGR. That's okay. Cool. So now let's plot this up. Just going to plot our spatial polygons data frame. And there it is. Cool. So that kind of matches up with each of these little water basins right here. So yeah, that makes total sense. But there's not really any data in it. So again, the shapefiles, they just hold the boundary. They just hold the polygons, and we might need an external file to actually plug in different data within these different water basins here along the Delaware coast. So now we're going to read in the CSV, water levels CSV, that's within the CFMS shapefiles folder. So let's go ahead and read that in. And cool, so this is what it's looking like. We have a couple of different stations, and there's basically one station per each of these different water basins right here. It has a given latitude, longitude, so that's nice. It's actually in lat-lon coordinates. And then it has a couple of these different water variables. The main one that we're going to be focused on is max prediction, and that is the maximum predicted water level in feet. So we're going to convert the stations to a vector. And so why are we going to do that? So let's print this out. And let's do a class on, so it's a character class. We kind of need this to be a vector. Excuse me, I forgot exactly what I was doing here. The reason that we need to do this is because notice that if we just print out the first 5 values of the coast shape station. So station is also a variable that exists up here. So coast shape has variables within it. So coast shape. So if we do $, we can actually query the variables here in coast shape. Station is also a variable here. But here's the bad news. If we look at coast shapes station and then we look at coast data station, they're not in the same order. So if we're going to actually add the data from coast data, the max prediction data, to each of these different stations that are geolocated within the shape file, we're going to need to reorder one of these so that they can match and be in the same order. So now here's what we're going to do. So we're going to order both of these different data sets, and we're going to do that using the order function. So we're just ordering all the rows of station right here. And now when I actually go and print out, now we're in the same exact order. So that's great. So that basically what that means is because they're in the same order now, we can merge these two things together because they're correlated. So, and keep in mind with this function up here, we're ordering not just the station row, but all of the rows within that data set are going to change with station. And so that's what's going on right here. The reason we leave all of the columns blank, is because we're taking all of the columns, we're shifting everything around so that everything is still, each row is basically attributed to the station. The station is the main row we're concerned with. So now that everything is ordered properly, we can merge these two different data sets together. So we can actually merge together from spatial point has a merge function. We've used other merge functions before, but this one is from the spatial points package. So we're going to make a data set called merged coast, and we're going to use the spatial points merge function to merge together our shapefile and our coast data. We're going to do that by the station variable. And we're also going to say that duplicate geometries is true. What does that mean? Basically, it means this. If you take a look at right here, this is coast, or here we go. This is after we order them, right? We have dbofs 001, dbofs 001, dbofs 001. Now, what does that mean? It means we have duplicates for the same station. So that's okay. Both data sets, the shapefile and the coast data, have multiple stations. Basically, what that means is we have multiple stations with each one of these particular water jurisdictions. So we just need to turn on this flag that just says there are duplicate geometries, so don't worry about it. So now we have a spatial polygons data frame, which is our merged coast. It's done it all by station. So now we actually have all of the data that was in coast data is now merged together within this shapefile. And notice that it is a spatial polygons data frame. So we are back up here, we are in the same class as coast shape. We just added this CSV data from that we read in as coast data. We just added that data. So basically all that happened is we copied over every single variable from coast data to coast shape except for station. Why? Because station already existed. So that was the merged variable. So in other words, that was sort of the row that we kind of used without making it the official row name, because normally we just have, our row numbers are just arbitrary numerical indexes. We basically chose to use station as our row, and we kind of merged these two together. So now we have the merged coast, which is great. And we're going to use, like we did last week, we're going to use my brewer palette, or our color brewer. We're going to use brewer palette from our color brewer, and we're going to use the blues color palette. And now what we can do, because we have a merged coast object that has all these different polygons, all these different all this different information for the shapefile, but also has this CSV file data merged within it, we can use sp-plot just from spatial points on our merged coast object, and the z column, basically the column that we want to plot. So it's going to plot the boundaries because it's a polygon, but we're also going to choose to color everything together, and the main variable that we're focused on is max pred, or max prediction. So there we go. We have all the boundaries that we already knew the shapefile contained and was able to plot, but now we also have the associated data in here with it. So for this particular data set on this particular day, we are not matching this day. This is a different day. So for this particular day, our max prediction for flooding was 3.6 down here, 3.6 feet above mean sea level, and then right here, this is our hotspot right in here. So there's a couple different ways that we can visualize data with this, and we can actually bring in the color right there. So sp-plot is pretty cool. I mean, there's a lot of different things you can do with it. It kind of works the same way that a normal plot function would. It does not work like ggplot. And notice how it's just one line, and we just kind of have, I added in these other par settings. You don't have to do that, but it just kind of help makes a couple things a little bit less. We added a title, we added cuts, and what those cuts are these different cuts between the colors right here. And we're using my colors, which we created up here, which is blues. So cool. So now we have, so remember those 5 cuts. So 1, 2, 3, 4, 5 cuts between these different water levels right here. And we just did that to match these particular water levels right over here. So yeah, there you go. I mean, that looks pretty good. It definitely plots the data, plots the shapefile, and plots the associated data with that. But what if we wanted to add a little bit more? So another way that we can do this is using a function called tmap. So tmap is it's a short for thematic visualization, and tmap works more similarly to ggplot. So notice that I bring in tmap and I query a tm shape, and I want that to be of merged coast, and I want to add polygons where I color them. I want to add polygons to our tm shape where I color them based on the max prediction. The title is projected water levels. The palette is blues. So we're going to add in a classic style, and we're going to scale the color bar down to the left and the bottom. Or sorry, it doesn't scale the color bar, it's the scale bar. So this is in kilometers down here, so it just kind of gives you a little bit of a metric for distance. But right, so we just added in, it's the same exact file, it just has more of a classic geographic look to it, but it still has all these different water basins and the max predicted water level. And it automatically made these cuts for us. So tmap is kind of nice. I mean, it offers a little bit of a different visualization, which is pretty cool. If this is something that you wanted to publish, it definitely would work well if you were kind of going for more of a historical look, which is pretty cool. But again, the main thing here is that we don't have any states around here. We want to add Delaware, we want to add the Delaware Bay, and we want to kind of see a little bit of Jersey. So now let's get into ggplot, and let's plot this shapefile using ggplot. So the first thing that I'm going to do here is I'm going to load in my simple features data frame. Now remember, we've been working with spatial points, SP. We need to convert this to a simple feature. So this is what we're going to do. We're going to load in the simple feature, and we're going to convert our spatial points polygon to a simple feature. So this can be done using this function st as sf. So now we have a new simple feature data frame called gg merged. And now we can use ggplot. So we're back using our geom sf, geom simple feature. So our data is gg merged, and the aesthetic fill is max prediction, the max prediction variable. And cool, there we go. So now we're on a ggplot instance. And just by the way, let's just take a look at gg merge really quickly. So cool, we have all this simple feature. It's multi-polygons. It has a bounding box. We still have our projected CRS. And then we have all of the different variables that are attributed with these different water basins. And right over here, here's our max prediction. So remember, that's feet above mean sea level for the next 48 hours. Okay, that looks good. And the other thing that I wanted to mention here that I haven't really talked about yet is this little grid back here. We don't necessarily need to keep that. This is called a theme. This is a default ggplot2 theme. So we can actually get rid of that or replace it if we put in, for example, theme BW. So now we just have a white background. We can do theme void, which can be very useful sometimes, as we'll see. So that just doesn't have anything in the background. We just have the raw data. Now theme gray. So now we're back to that gray background. Theme classic. So ggplot has these different themes, and we're going to see that they can be useful. So they'll kind of all have a different aesthetic look, and it's really easy to query because you just have plus theme, whatever. And we have theme light, theme dark, a whole lot of different things going on here. They can be useful under different circumstances, and here's why. We want to add states to this. We want to add Delaware, and we want to add a little bit of Jersey. We want to see the Delaware Bay. Within our course datasets, we have right here world shapefiles. And we also have, that we're actually going to be using here, North NE 10 meter admin 1 states provinces. I believe this stands for Northeast 10 meter resolution state provinces shapefiles. So what this is it's just state shapefiles, which is great because when we read this in, we're going to use our read OGR function to read in this shapefile again, and there we go. Now we have states read in. So there's a lot going on here. We have very high resolution shapefiles of these states right here. So there we go. We have 83 different variables, and we're in a lat long projection. Have a ton of features. And so, for example, if I do states $ to query just the variables, we have all these different names, all these different variable names, latitude, longitudes, map color, postal number, region code. So there's a lot going on there. And then we also have our different prod string, which is just lat long, and different things that we can query like that. So again, we read this in, so it's going to be a spatial polygons data frame because we read it in with read OGR. So first thing we have to do, because we're going to be using ggplot, is we need to convert this over to a simple feature. So just use our st as sf function again. And now what we can do is we can just add our states data and our GG merged with a max prediction fill, and we can add states. So this might take a little while, especially don't do it the way I just did it. That was bad because I did not give it a coordinate limit. So what's going on here is it's probably trying to plot all of the states in the United States of America, and then also the data over this little sliver of Delaware. So don't do what I did. I was just trying to show that you only needed these two for it to actually work, but it'll make it incredibly slow. So just make sure that you add in everything. So remember, we're going to use our coord sf to give it limits. We're going to put expand on the equals false so that we only have the data that we're focused on. And here we go. Now we actually have this data right over top of the state of Delaware, which is awesome. And ggplot automatically handles these projections for us. Which is great. And we can actually just take a look at this. So even though we have these different simple feature data frames, we still have the coordinate reference systems stored in there. So it's actually doing a reprojection on the fly. And what we'd actually see is if we actually had a finer resolution shapefile, so I can tell you that my analysis of this is 10 meters, completely wrong. It's probably 10 miles. And so basically we're really smooth along the edges. If we actually had a finer shapefile right here, then it would actually fit this coastline just right. So another key thing here that I just wanted to talk about is we used the void theme right there. So I'm going to remove the void theme and I'm going to plot it now. And notice that it just kind of made, because we didn't color anything, it just kind of added in this nice gray box. So that's why we use the void theme right there. At one point, there was a bug. I'm guessing that it fixed it now. But at one point when I was creating this, you needed to use the void theme for this to run at all. But it seems that they have fixed that, which is cool. So now you don't necessarily need it to run, but it makes it just look a lot nicer, a little bit cleaner, and you can use a different theme of ggplot. So that's kind of nice right there. And we also added in this scale fill distiller, and what that is we automatically read in this default blues color palette that is associated with ggplot. So this is a ggplot function, and we gave it a direction equals 1. What does that mean? It means that we had lower blues for lower water levels and darker blues for higher darker levels. So this just reversed the natural direction, which typically goes dark blue to light blue. The last visualization that I wanted to show here is called map view. And check out how easy this is. So we throw in map view, load it up. You're going to have to install it if you don't have it installed yet. And then I'm just going to copy over this quick line. So all I do is I say I want a map view of merged coast max pred, that variable. Now this function is automatically going to look at, because this is we're now working with merged coast again, so remember class merged coast is a spatial polygons data frame, and this is with our merged CSV data. So it already has all this other shapefile information located in it, and we're going to add my colors, which is our color brewer result right there. Now watch this. Just this simple line right here, and we get an interactive map right here. Just so fast. Just that one little line of code. This is a really cool function, let you visualize data and mess around with it, which is awesome. Has a really nice map behind it too. Just a lot more. So notice how I remember earlier I said that the shapefile folder that we were using was 10 miles, so it was really smooth along the edges. Now we actually have one that's tighter, and we fit the edges just right. Yeah, so map view is awesome, and it only took one line of code to do that after we merged the data together. And you can do the same thing online too, because it's an HTML-based thing. So the last thing that I just wanted to talk about is we merged together this folder, or this file, right? So we merged together this file. We merged together our shapefile with our actual raw data, and we might want to save that so we don't have to do that again. We've read the shapefile in read OGR. If you want to save a shapefile, there's a function called write OGR. So you can actually save the shapefiles, and I'm actually going to go through and do this, right? So we're gonna save merged coast, and I'm gonna save it just right here. I'm gonna save it into my downloads folder, and so DSN is for destination. The layer is coast RGDAL, and if we actually go to write OGR, if we go to help, it's the layer name. It varies by driver. And the driver that we want is the Esri shapefile. So that's the type of shapefile that we want. So if I run this, now this doesn't work. Why? Because I don't have a coast files folder. So if I actually go over here, go to downloads, and I go to, what did I name it? Coast files. Now we have a coast files folder, and now when I run this, just returned a warning. That's okay, whatever. But now if I come over here and go into coast files, now we have a merged.coast, and then there we go. The layer, this is just the name of the shapefile that goes within merged coast. We have, look at that. It automatically wrote for us a shapefile, SHX, proj file, and a DBF. So there you have it. All of these files stick together. They always have to stick together with shapefiles. It's just the way it is. And you can save it using this line right here. So for the assignment, you're going to use the Parks and Protected Lands dataset. It's a shapefile dataset. And I would like you to map the names of protected lands. The variable name is just name. In the Pacific Northwest. So you'll need to work with the folder. So if you actually come over here and you go to datasets and parks and protected lands. So it's a ton of data. So that's why I said if you download it the original way, it's a lot better. But the only one that you really need to read in, right, is you're mostly just concerned with you're probably just mostly concerned with each of these shapefiles. We just have an area, we have a land, and you're going to be concerned with land's area. Yeah, that is going to be the one that you care about. And actually, let me just double check that. Come over here, I might add a little description to that can probably be a little confusing. So yes, you're only concerned with the land's area, that shape. And I'll make an adjustment so you don't have a hang up right there. I'll add the adjustment to the assignment right there. So anyway, you're just going to be concerned with the area, and you're going to use this bounding box, and then you're just going to try and recreate these three maps. So the three maps are one is using tmap, one is using ggplot, where you actually add states to it, and then the last one is map view. And so what I'd like you to do is create the three plots, try and get them as close as possible to this, and then save the plots either as a PNG, or you can take, for this plot, you can take a screenshot of it if you'd like, and just upload the three plots. You can put them in a document if you want. You can upload them individually, I don't care, but just submit them to Canvas.